Hi there, this is Eileen Chevalier, and today we are going to look at Eileen Chevalier's typewriter alphabet, Botany flashcards, and learn about roots. Root systems are just as diverse as stems and leaves. In this lesson, we'll look at roots, one of the three main plant parts. We'll compare fibrous roots and tap roots, find roots that store food, and check out some other root features. All right, so the materials that you guys are going to need today, your journal, of course, and the flashcards, as well as the DK Ultimate Visual Dictionary and the DK Smithsonian Floral Book. Both of these have really amazing illustrations of roots. So go ahead and get out your journal, and I will read some definitions to you, and you can write them, well, just one. I'll read a definition for you and you can put it in your journal. Root, part of the plant, usually underground, that collects and transports nutrients and water to the stem, anchors the plant, and often stores nutrients and food. All right, so our first section is question and investigate. The Ultimate Visual Dictionary says that roots are, quote, the underground parts of plants. But is that always true? Like, that is kind of what we think, right? The roots are underground. We all know this. The part of the plant that's underground is the roots. Mostly, that is mostly true, which is why in the definition that I gave you, I said usually underground instead of always underground. Because we just needed to look a little deeper. Plants are so diverse, and to say that something is always true is a really tricky thing because there's just so much diversity and plants are super surprising. Can you think of roots that are not underground? And can you think of stems or leaves that are underground? If you look in Flora on pages 38 and 39. All right, so let's look at this picture in Flora. So we have all of these green tendrily things hanging down are actually roots, just like we saw with the orchid roots in the Monocotyledonii video. They're covered, the roots themselves have a protective covering over them that actually photosynthesizes, and the roots aren't underground. They're just literally hanging out in the air, and very different, right, than we would think. We think that roots need to go underground, but they don't always. So orchids can grow and other plants can grow just on the side of a tree, so they'll attach themselves to the side of a tree. Usually it's like a little area with not like just the bark of the tree, but it'll kind of dig in, and other vegetative organic material will be there. And so it anchors itself, and then it hangs these roots down. They're called aerial roots. And then another thing that's really fun is contractile roots. So if you've ever seen a bulb, like if you buy a bulb at a store, then you just hold it in your hand and there are no roots there. It kind of just looks like a seed. And in fact, it's not a seed, it's already the plant. And when you plant it, the roots will come down. And so the roots aren't even always present, but the thing that you're putting in the dirt, if the roots aren't present yet, what are you putting in the dirt, right? It can't just be the root part of the plant. It has to be the stem and potentially the leaves. So we're going to do a whole lesson on bulbs called knot roots, and you can see what's going on in there. But just know that there are lots of other plant parts that are underground, and we generally so far we're just talking about the ground, but there's also water, and there are lots of aquatic plants, and so it doesn't even have to be underground, it can be underwater. So what's happening with the stems and the roots when they are water plants? Second question. Roots usually send out tiny root hairs. How would this help the plant do its three main jobs? So what were the three main jobs that look back at your definition and you can see It is the collection and transportation of nutrients and water, anchoring the plant, and storing nutrients and food. So how would all of those teeny tiny little roots help to do that? If you've ever tried to pull up a plant from the ground, so the anchoring, right? So how is it helping to anchor it in when it has all of those teeny tiny root hairs? What if it didn't have them? What would happen? It's actually fun if you just want to like go outside and actually try to pull them up. And then if you've ever, like when you first plant something, I'll show you a really quick example. I happen to have one of my avocados right here. So this guy has a pretty large root down in the middle, and it's getting one on the side. But this is just the very beginning. So if I were to plant this right now and then try to pull it up, it'd be really easy because it's just like a thin root going into the ground. Plus I just planted it so it hasn't like solidified itself in there. But as it gets those tiny root hairs in there, then it helps to grab on and hold. So same thing with the nutrients. If it's just that single piece, where is it able to get nutrients from? As opposed to if it has all the little tiny root hairs, it's able to get nutrients from a lot of different places. All right, third and final question. Compare the roots of monocots and dicots. In addition to the different structure within each root, Visual Dictionary 126 through 27, which you've probably already seen, the overall structure is also different. Compare the fibrous roots of monocots and the tap roots of eudicots. So in Flora, the very first part of the roots, so they have all these different sections. Roots is the first one. And on the first page, it shows you this really gorgeous example of a fibrous root. And then on the next page is a classic example of a taproot. Now, this is a very round taproot. So this one is doing a really special job. So those 3 jobs that the roots do, this one is doing a great job of one of those, which is to store nutrients. And this is why we eat root vegetables, because they're so nutritious, because the plant may or may not be trying to feed us. It's definitely trying to keep itself fed. So it stores all this nutrition into the roots. And over time, as humans found these things and started eating them, they kept selecting for the ones with the biggest, juiciest tap roots. And so that's what we have now, are these gorgeous, luscious root vegetables. So you can even see, I'm going to show you this one more time so you can see the root hairs on there as well. So even though the main part of the root is this tap root that's very, very fat, it still has all these little tiny hairs because those are bringing the nutrients and water and everything like that to the central part of the root. All right, so those are the 2. Do you know which is which? Like I just showed you, and I showed you an avocado with a taproot, and that is actually a magnolia dye, but it has a dicot root type. So the dicots and the eudicots have the taproot, and then the magnolia dye, the monocotyledonii are the ones with the fibrous roots. So actually, I thought it was really fascinating that the pesticide or herbicides that you use, and hopefully you don't use, that people use in their yards, what they do is they attack eudicots and kill eudicots, and they leave the monocots there. And the monocots are the grasses. So if you have a dandelion, a bunch of those in your yard, those are all eudicots. So what it's doing is it's a little complicated, but it's interesting that it's killing all the ones with those tap roots rather than the ones with the fibrous roots. All right, and now let's look really quickly at the Visual Dictionary. For these, we saw that before when we were looking at the monocots and the eudicots, what their roots look like. So the internal structure of the root is different, but also how the branching of the root itself is also different. So in your journal, we have a couple things for you to do today. The first is kind of fun. You can go dig up a small but deep area in the soil, or if you don't have access to soil, I'm sure you can find a good diagram on the internet. Notice how the soil around the roots is different from the soil below it. So the soil changes as it goes down. It changes in texture, it changes in nutrient content, it changes in organic matter. If possible, dig in soils with different structures: clay soil, sandy soil, garden soil. Are the roots the same in all three? What are the roots doing, and what type of plants are most inclined to grow in those spots, right? Use pictures to record your findings. So again, we're just kind of going out, seeing what's happening in the real world in these different types of soil, and then record what you're finding. And this one's a really interesting one, so kind of think about that and come back to it. What types of soils are growing what types of plants, and how, if you have a garden, then it'll be really interesting for you. Like maybe you've germinated some seeds and you're going to plant them outside. So at the end of the season, or when that plant is really large, just dig down into the soil and see what's happening. You can sometimes I can do this with potted plants when I transfer them into a larger pot. I did this recently and with some succulents, and I had put them in a really large pot because that's what I had, and I liked the pot. And they had only really taken up the soil at the very top, and so all the rest of it was totally different. Like the structure of it and how it fell apart and everything when I was taking that was really different. So it's fun to see what's happening with the roots. And if you read in, I know this isn't on today's, but if you read in Grow Your Soil, she explains a lot about that relationship that's happening between the organisms in the soil and the roots of the plant. All right, next is look at the roots of a plant for yourself. Try buying a plant at a nursery, pulling up the small weeds after the rain, or using a shovel to get deeper roots. Can you find the taproot, or is it a fibrous root? How dry are they? How wide? How long? How deep did the roots go? If you were able to pull up more than one, try comparing the roots and see how they're different. Record your observations. So roots are amazing. I used to do a lot of weeding, and I could tell like what I was pulling up by the way that it pulled out of the soil. So fibrous roots pull out differently than tap roots, and so just the way that they kind of like tug and hold onto the soil is different. And then there are roots that, because they're self-propagating themselves, they kind of run horizontally underground, and actually that's most likely a stem now that I think of it. But some roots are to go very deep, and then some roots spread out very shallow. So if you look after a storm, sometimes a tree will fall over, and you can see how the roots spread out to the side and how deep they got. And you can kind of compare those things, which I think is super interesting. And why did the tree fall over? Perhaps it was because of the root structure, like, or how the root was working within the soil. So just kind of keep those observations, draw some, and even I'm sure you can find pictures of that as well if you don't have access to actually digging those up for yourself. But there are many, many, many variations, and we just don't really see them, so we don't think about it. All right, good luck digging into the roots and finding out more about those. We'll see you in the next lesson. Thanks, guys.